Right, good day, Matrix. Okay, a quick little video on integrating using partial fractions. And if you know partial fractions, this really is an easy form of integration. So let's have a look. So as I said to you on the plan, okay, there's two quick sums we're going to do with you using partial fractions. So if you looked at this, substitution is not going to work. Actually, will it work? If I let u be equal to x squared minus 6x plus 8, you get 2x minus 6, x minus 3, no, wouldn't work. Okay, so substitution wouldn't work here. If it had been x squared plus 6, it would work, but x squared minus 6x isn't going to work. So they normally tell you resolve into its partial fractions and hence integrate. Not always, but most of the time, they tell you which method to use. So what often the question says, resolve into partial fractions, hence integrate this. Okay, so they normally do give you some kind of guidance. So first of all, I'm just going to say, let's just look at the partial fraction. So it's going to become x plus 3 over x squared minus 6x plus 8, which integrates to x plus 3, x squared minus 6x plus 8 becomes x minus 4, am I right? Yeah, x squared minus 6x plus 8, what does that equal to? X minus 4, x minus 2. X minus 4, x minus 2. So I get x plus 3 over x minus 4, x minus 2. Okay. So now to resolve that into partial fractions, it becomes a over x minus 4 plus b over x minus 2. Okay. So I end up with, therefore, times by the denominator, by the LCD, and I get x plus 3 is equal to a times x minus 2 plus b times x minus 4. And the easiest way to solve this, if you remember, is to make the a's and b's disappear. And you can make the a's disappear by letting x be equal to 2. And if x is equal to 2, I get 2 plus 3 is equal to b 2 minus 4. So I get 5 is equal to negative 2b. So negative 5 over 2 is equal to b, right? And if I let x be equal to 4, that's going to make the b's disappear. Okay, so if x is equal to 4, and if x is equal to 4, I get 4 plus 3 is equal to a 4 minus 2. So 7 is equal to 2a. So 7 over 2 is equal to a. So this sum becomes, okay, so this whole thing, so x plus 3 over x minus 4, x minus 2 is in fact equal to a over x minus 4, which is 7 over 2x minus 4, plus b, which is minus 5 over 2x minus 2. Right, so that has become that. Okay, and now I'll go back to the top over here. Whoa. Okay, I was trying to integrate that whole thing over there. I pulled that star. So then this will become, that sum star will become the integral of, I just put that in there instead of the original one, 7 over 2x minus 4 minus 5 over 2x minus 2 with respect to x. And if I want, I can just go, right, this is the same thing as 7 over 2 times the integral of 1 over, you can obviously skip out steps, x minus 4 with respect to x, minus 5 over 2, integral of 1 over x minus 2 with respect to x. Okay, and if that is an integral of 1 over x minus 4, is going to be 7 over 2 ln absolute value of x minus 4, or the derivative of the inside function x minus 4 is just 1, so it's times by 1, so you don't have to worry about that, minus 5 over 2 ln absolute value of x minus 2 plus a constant. So usually with these ones, we're using partial fractions. The actual integration is normally pretty straightforward once you've done the partial fractions. So as I said to you, normally they'll say to you, use partial fractions to decompose and then hence integrate or something like that. Okay, so there is the final answer. 7 over 2 ln x minus 4 minus 5 over 2 ln x minus 2 plus c. Righty. Okay, pause the screen, make sure you've got all of that down. Straighten it up for you a bit. Okay. Right, so that's that over there. Right, the next one. Okay, remember these top heavy ones. Okay, so again, they say to you resolve it into its partial fractions normally and hence integrate. Substitution wouldn't work. You get 9x squared plus 10x plus 9. Nothing's a derivative or something else. Okay, so we are going to have to do the partial fractions. So to do the partial fractions, we have to divide out first, that force and balance method. So I've got 3x cubed, it's going to be a very long sum, plus 10x squared plus 9x plus 5 over x squared plus 2x plus 1. Right, so go try to do the division. Remember that force and balance. Off you go, press pause and come over to check you got the right answer. So you're going to have to force x squared plus 2x plus 1. Oh, shut up, hardy dogs. Into the sum x squared. And so to do that, to get x squared plus 2x plus 1, what I have to take out? 3x. So I take out 3x, x squared plus 2x plus 1. And it's going to be all over x squared plus 2x plus 1. Got to balance this. So I get 3x cubed, which is fine. But now I'm sitting on 6x squared. But it should be 10x squared. So how do I balance 6x squared? Okay, I add 4x squared. It's going to be plus 4x squared. So I get 6x squared plus 4x squared is 10x squared. With the x's, I've got 3x, but I should have 9x. So it will be plus 6x. 3x plus 6x is 9x plus 5. If I divide out, that divided by that gives me 3x. And I'm going to have plus. I want to force x squared plus 2x plus 1 to be in the sum again. Okay, to get x squared plus 2x plus 1. Okay, what am I going to have out here? Well, I'll just look at the 4x squared, so that's going to have to be 4. Okay, so I get 4x squared plus 8x, but I want 6x. So I've got a minus 2x. Plus 4, but I want plus 5. So it'll be plus 1. So I end up with it being equal to 3x plus 4. I always prefer to put a plus sign in. Plus minus 2x plus 1 all over x squared plus 2x plus 1. Right, so that's the division part of that done. Okay, now I need to simplify this bit over here. I actually have to do a partial fractions part of the sum. So I've got minus 2x plus 1 over x squared plus 2x plus 1, which is the same thing as minus 2x plus 1 over x plus 1 times x plus 1, which is x plus 1 squared. Remember, be careful of the squared version over there, x plus 1 squared. So that we can write as a over x plus 1 plus b over x plus 1 squared. Okay. Get rid of the denominator. So I'm going to have negative 2x plus 1 is equal to a times x plus 1 plus b. Okay. So I'm sitting with that over there. Well, we can get rid of the a pretty easily by letting x be equal to negative 1. And if x is equal to negative 1, I get negative 2 times negative 1 plus 1, which is going to be, that's going to disappear, plus b. So I end up with 2 plus 1, so b is equal to 3. Right, so b is equal to 3. So this sum becomes minus 2x plus 1 is equal to ax plus 1 plus 3. And to figure out what a is, well, we can equate coefficients. So I could look at the x's or the constants. I'm going to pick the x's. If I look at the x's, on the left-hand side, I've got minus 2x. And on this side, I'm going to just have ax. So in other words, a is equal to minus 2, right? So in other words, this whole bit of the sum over here, okay, this bit here is equal to a over x plus 1 plus b over x plus 1 squared. So a is 3, so it's equal to 3 over x plus 1. So that's 3 over x plus 1 plus b over x plus 1 squared. Ugh, a is minus 2, apologies. So I've got minus 2 over x plus 1 over x plus 1 plus b, which is 3 over x plus 1 squared. Right, so that is that bit over there. So in other words, this whole sum, this integral over there, I'll go back here. Boop, boop, boop. Right, sorry, all kinds of phone calls going on in the background here. Okay, so this sum over here, that star bit over there, I just use a star. So that's going to become the integral. Well, that whole sum simplifies to this whole thing over here. So it'll become 3x plus 4 plus negative 2x plus 1 over x squared plus x plus 1 became negative 2. So it'll be plus, so it'll be minus 2 over x plus 1 plus 3 over x plus 1 squared. Okay, so I've got 3x plus 4 minus 2 over x plus 1 plus 3 over x plus 1 squared. That's what this whole, the whole original sum has become. Okay, so that's it over there. So now I've just got to go integrate this part over here. I hope I haven't made any careless mistakes, by the way. So if I go integrate that over there, the integral of 3x is going to be x squared over 3 plus 4x minus 2. 1 over x plus 1 is ln of the absolute value of x plus 1. Okay, here, remember, I'm just going to go do a little bit of cheating over here. It's going to become 3x plus 1 to the minus 2. So if I integrate that, it's going to be 3, add 1, x plus 1 to the minus 1. So if I differentiate it at the moment, okay, I'll get minus 3, x plus 1 to the minus 2, but I want to have plus 3 over there, so this in fact must be negative 3. The derivative of the inside is just 1, so I don't have to worry about that, plus c. So if I want to make the final answer prettier, your final answer is x squared over 3 plus 4x minus 2 ln absolute value of x plus 1 minus 3 over x plus 1 plus c. And there is the final answer. Okay, so we did the division first. Okay, divide it out, got the answer. Remember, you've got to do that partial fraction bit over there. We did that over there. That partial fraction became that. So in other words, the whole sum became that. And then the integration of each bit is pretty easy. Have I made a mistake here? X squared over 2, that should be. What a dumbass. Okay, so that's the x squared over 2. Okay, plus 4x minus 2 ln x plus 1. That became plus 3. 3x to the plus 1 minus 2, add 1, so it becomes x plus 1 to the minus 1, divide by that. Yep, that looks right to me. Okay, right, so you've got some homework. What to write it down, but it's on the WhatsApp that I sent you. Okay, just give it a go, please, guys. And that is that. Okay, we are slowly eating up integration. Whew, it's the longest section in the world ever. Hope you're having a good sort of vaguely kind of holiday. Arrivederci. Ma'am says arrivederci. Or Mexican version. Farewell.